All right, so if you're a DBA who basically grew up on SQL Server, making the jump to Oracle can feel, well, a little like landing in a foreign country, right? The language seems totally different. But here's the thing, the fundamental concepts are exactly the same. So in this explainer, we're going to be your translator, starting with the most basic building block of all, storage. Does this feel familiar? You're staring at Oracle documentation and all these new words are flying at you. Tablespace, data block, and you're just sitting there thinking, I just want to store my data. It can honestly feel like you're trying to learn a completely new language from scratch. But here's the big secret. You already understand the core concepts. You've been managing this stuff for years in SQL Server. The challenge isn't learning database architecture from the ground up. It's just about mapping Oracle's terminology to the knowledge you already have. So, let's get started. Let's translate. Okay, let's start at the absolute ground floor, the atomic level. In any database, all your data has to live in some kind of fundamental unit on the disk. In the world of Oracle, we call this a block. Now, the main thing you've got to remember about an Oracle block is that it's the smallest unit of I/O. When Oracle reads from a disk or writes to it, it never, ever grabs anything less than a full block. This is where your individual table rows, the actual data, physically live. And what's really cool is what's packed inside this tiny unit. Every single block has a header with metadata, a row directory that acts like a little table of contents for the data inside, the actual row data itself, and, this is super important, a little pocket of free space saved for future updates. And boom! Here is our very first direct translation. An Oracle data block is, for all intents and purposes, identical to a SQL Server data page. Both are usually about 8 kilobytes. And remember that little pocket of free space? In Oracle, you control that with a parameter called PCT_free. In SQL Server, that's your fill factor. See? Different names, same exact job, leaving room so your updates don't kill performance with fragmentation. All right, so we've got the individual bricks covered. Now let's zoom out a bit and look at the containers that hold all those bricks. How do we group these blocks together in a logical way? Well, in Oracle, that happens at the tablespace level. So this logical container is called a tablespace. And trust me, as a DBA, you're going to use these all the time to group related stuff together. For example, you might create one tablespace just for an application's data and a completely separate one just for its indexes. It's a really powerful way to keep things organized. But, a tablespace is just a logical idea. It has to actually point to something real, something physical on the disk, right? Well, that physical piece is the data file. A single tablespace can be made up of one or even many data files. The folder analogy here is perfect. The tablespace is the folder, and the data files are the actual files inside it. And this brings us right to our next major aha moment. An Oracle tablespace is the direct equivalent of a SQL Server file group. An Oracle data file, that's your SQL Server data file, your MDFs and your NDFs. And that special tablespace that Oracle uses for sorting and other temporary stuff, the temp tablespace, yep, you guessed it, that's your temp DB. It is a direct one-to-one mapping. Okay, theory is awesome, but we're DBAs, right? We build stuff. So how do you actually go about creating one of these table spaces? Let's take a look at some code. Now, don't let this syntax scare you off. It's actually way more descriptive than it looks at first glance. This command is simply creating a table space, pointing it to a physical file, giving it an initial size, and then telling it exactly how to grow when it needs more space. Let's break that down. It really just boils down to 3 simple steps. First, you name your logical container. In this case, app_data. Pretty straightforward. Second, you define its physical home by pointing to a data file on disk and telling it to start at 10 gigs. And third, you automate its growth so you don't have to get paged in the middle of the night to resize a file. Simple, yet powerful. Okay, great. You've built your storage. Now what? How do you keep an eye on it? How do you check your free space or see the properties of your files? You need a way to query the database's own internal metadata. You know how in SQL Server, you're practically living in system views like sys.databases and sys.file groups to see what's happening? Well, Oracle has the exact same thing. They just call them data dictionary views. These are your windows into the health, the configuration, and the space usage of all your storage. And here it is. This is your monitoring cheat sheet. Seriously, you might want to grab a screenshot of this one. To check on your logical containers, just swap out sys.file groups for DBA table spaces. For the physical files, replace sys.database files with DBA data files.
And to see how much free space you've got, trade sys.dmdb file space usage for DBA free space. The purpose is identical, only the names have changed.
So let's just boil it all down, right? The key takeaways. When you see Oracle block, your brain should just translate that to SQL Server page. When you hear Tablespace, think file group. And when you need to check on things, you'll be using data dictionary views instead of system views. You haven't had to learn a whole new way of thinking, you've just learned a new dialect.
And just like that, you've cracked the code on Oracle storage, all by using the SQL Server knowledge you already have. See? That feeling of being lost starts to fade away pretty fast when you realize it's not a whole new map, just a different legend. So what's the next Oracle concept you're ready to translate? Maybe we should tackle redo logs versus transaction logs next?